Hello and thank you very much for the kind introduction. My name is Henning Seil from Pleach, the guys behind the app store SolidWorks. Today I would like to show you the stair and railing features in SolidSteel parametric for SolidWorks. We will take a closer look at some newer functions such as splitting stair stringers and creating sheet metal stringers. At the end of the webinar the stairs will look roughly like this and the whole session will take about 20 minutes. Let's start with this initial situation. We have a simple wall with a door opening that's not flush with the floor. We need a staircase here, and in SolidSteel that is very easy using the stair feature. To create a stair we only need two sketch lines. I select the start line and the end line, and we immediately get a preview. The fact that the stair already fits so well is no coincidence. SolidSteel always remembers the last used inputs, and of course I already tried this once before the webinar to check the timing. But now we will take a closer look at the available settings. In the dialog, we can first choose whether the stair stringers should be made from profiles or from sheet metal. In this first example we will keep profiles. Below that we can define the profiles in detail. The selection order goes from large to small. First regional assignment, then the profile shape, then the profile series, and finally the profile size. Using the same principle we can select the stair steps below. By clicking Configure, we open the dialog to define the actual stair parameters. In the first tab, we can define the position of the stair on the start line. For example, we could center it. In our case, right aligned with an offset of -508 mm works better. In the second tab, we define extensions. At the top, we have a horizontal extension of 800 mm for the landing. We can easily change this to, for example, 1200 mm. We immediately see the effect in the preview, and at the same time the calculated parameters on the left update as well. Now we see a red value for the going, which tells us that we are outside of adjustable standards or limits. The default values in SolidSteel are based on DIN 18065. I switch back to 800 mm. Now the going is longer again, the stair angle is flatter and overall more comfortable to use. At the bottom of the stair we have a vertical extension of 180 mm, which we can adjust in the same way. In the next tab we can define a floor offset to compensate for a possible floor build-up. In this example it could be a grating with a thickness of 30 mm. If I delete the 30 mm we can see how the steps rearrange themselves. The distribution is always even and we don't need a calculator to determine riser heights. I enter the 30 mm again. If this were a checker plate on the landing, maybe 5 mm would be sufficient. At the bottom of the stair we don't define a floor offset, but instead we add an extra step which we can enable or disable using this checkbox. The next tab also focuses on the steps. Here we can shift the steps horizontally relative to the front edge of the stringers. We could also manually define the number of steps here. However, this is almost never necessary unless you want to create stairs far outside of common standards. In the last tab, we now come to a new feature that has been available since SolidSteel Parametric version 7, the cuts in the stringers. This makes it very easy to split large welded assemblies into more manageable parts. For this stair we could place cuts in two locations, but for this small stair one cut positioned relative to the bottom edge is sufficient. We can now close the dialog. The stair is fully configured and we can confirm to insert it. This takes a short moment while the profiles are positioned, mitered, and the holes and bolted connections are placed. This requires a bit of patience, but compared to manually modeling such a stair it is of course extremely fast. And here it is. We just saw the cut in the stringers as the last step in the dialog. At this position we now place miter plates to create a stable connection. This is very easy. We only need to select the profiles to be connected. We already see the preview and I have saved suitable plates as a preset beforehand to keep the webinar short. After activating the pin I confirm so the dialog stays open. We still need to place another miter plate. Okay, the same thing on the other side. Confirm. Done. Now we can close the dialog. Alright, the stair was quick. But now we also need a railing, and of course SolidSteel Parametric provides a feature for that as well. In the dialog we can see at the top that a side-mounted railing is selected. To place it we need a mounting face and an edge that defines the railing direction. We immediately get a simple preview of the railing. Just start, end and height. No further details at this stage. Just like the stairs, railings are also parametric. For example, we can shift the start point so that later, when fastening the railing, we avoid conflicts with the already existing bolts. Everything else fits. As mentioned before, SolidSteel remembers the last inputs. This is very practical for recurring tasks or webinars. I have pinned the dialog again because more railings will follow. Now we can watch the software work for a moment. Railings are template-based and controlled by equations. This means you can create your own railing templates once, store them in the database and reuse them at any time. Which parameters are adjustable depends on the quality of the equations, but almost anything is possible. When a railing is placed, an independent copy of this template is created and then adjusted. The original templates are never modified. Here is our first railing. The parameters we just mentioned can be seen in the lower left of the dialog. For example, mounting distance, height, number of segments, number of bars per segment, and so on. It would be tempting to continue building the railing at the top right away. But since everything is set correctly, it's smarter to first place the identical railing on the opposite side. Because it is mirrored, we need to swap the start and end offsets. Everything else can stay the same and we can confirm to insert the railing. Now we have another short pause of about 30 seconds while the computer does the work. Again, an independent copy of the template is created, parameters are adjusted, parts are placed and cut. The duration depends on the computing power of the system. The computer I'm using here is a standard laptop that is already a few years old. Okay, the second railing is now placed. What is still missing are the short railings on the landing. The general steps are exactly the same as before. The offset of 730 mm to the profile end no longer fits here, so we change it to -100 mm so the railing ends in front of the wall. Since railings are always created with at least 2 posts and that would be a bit too much here, I now move the front post so that it aligns exactly with the last post of the first railing. In this case, that happens at -20 mm, but of course this varies depending on the situation. In the equations we change the number of segments to 1 and confirm. We know this already. The computer works for us again. Here's the railing. The handrail looks a bit unusual, we will fix that in a moment. First we insert the second short railing. The offsets on this side must be swapped again. Confirm and wait briefly, as expected. Here it is. We no longer need the dialog. Now we take care of the handrail and add a miter cut. We find this in the feature Cut on Profiles. Simply select both handrails and confirm. We do the same thing on the other side. The fact that the handrails disappear into the wall is also not ideal. Here we use the feature Cut on Face. First we select the face and the green arrow shows the cutting direction. If this is incorrect, we can activate the reverse cut direction checkbox. Since the feature allows multiple selection, we can select both handrails at once. The defined 30 mm offset is fine, so we can confirm. That already looks much better. You may remember that we placed the railing posts on top of each other earlier. To ensure the bill of materials is correct later on, we now select the parts of the redundant post and suppress them. The small round bar as well. With that, the railing would be finished if it were welded. However, it would not make much sense to split the stair stringers for transport and then continue planning with a fully welded railing. Therefore, we now add small end plates and bolt the railing instead. First we select the short flat bar and then the face it should be bolted to. We immediately get a preview. Again, I have saved a template for the end plate in advance. You should do the same for components you use frequently. It saves a lot of time. Using the arrow keys here, we can browse through the dialog pages. Here we see the plate dimensions. On the next page we see that punch holes at the top is selected and that a complete bolted connection with bolt, washers and a nut is already defined at the bottom. We can confirm. This again takes a short moment during which the software places the plate, performs the linear cuts for the holes and inserts the bolted connection, which in this case consists of 6 parts. So quite a lot actually happens when inserting the small plate. We now repeat this for the remaining posts. Since SolidSteel remembers the last parameters, we can simply confirm directly after selecting. Here the plate sits exactly on the miter cut of the stringer, so I also select the second face. Alright, one more on this side. To keep the webinar short, we will skip inserting the end plates on the other side. The procedure is exactly the same. The stair and railing are now finished. But SolidSteel Parametric does not stop at pure modeling. It also supports subsequent processes such as shop drawings and bills of materials. First, we automatically assign position numbers. By the way, you can define the position number ranges according to your own standards. In the bill of materials area here at the top, we find the feature update metadata, which ensures that all properties are written into the corresponding parts. We keep the default settings and confirm. This takes a short moment. You can tell the process is finished when the icons at the top turn colored again. Okay, the process is complete and we are ready for the subsequent processes. Let's start with a shop drawing of this profile. I only clicked it briefly so that I can see the name in the feature tree. For drawings, we have a dedicated feature that starts the drawing assistant. We have already assigned position numbers and changed nothing since, so we don't need to repeat that step. The drawing assistant alone would be material for a separate webinar. In short, it allows you to define sheet sizes and other general settings in one place and most importantly manage all drawings and their update status centrally. I now select only this single beam for drawing creation because exporting all drawings will take several minutes. I enter a name for the order number, set the action to create and export. We see something like a short animation showing the drawing being created. And then we get the message that the drawing is finished. We have basically already seen it, but I will open it briefly anyway. The drawing is not spectacular, but as you can see, everything was dimensioned automatically and all views were created. We could now adjust the dimension chains using standard SolidWorks tools or add an isometric view, for example. I will close the drawing again. Next, we generate a bill of materials using the feature with the same name here at the top. In the dialog we can select templates. I choose a metric one and set the language to English. We specify a file path and name and confirm. The icons are colored again, so the bill of materials has been exported. Let's take a quick look. It is saved in Excel format and of course you can customize the BOM templates to your own liking. On the individual sheets we have the bolt list, the saw list including all angles, the structure list sorted by assemblies, the profile list sorted by profile types, the plate list normally sorted by thickness but here we only used one, and the quantity list which contains everything once. Okay, that was a lot in a short time and it also took a bit longer than planned. But now let's take a quick look at another new stair feature. The initial situation is identical to the first example. That's perfect because we only need to select the start and end lines again. The preview looks the same as before until I switch the profile type to sheet metal. Okay, that doesn't quite fit yet. We need to adjust the plate size. A height of 200 mm and a material thickness of 12 mm should work. Yes, that looks good. As you can see in the preview, the plates are currently handled exactly like the profiles before, including all existing cuts. However, for sheet metal stringers there is of course also the option to create the stringer as a single continuous plate cut from the steel sheet. We switch to the last tab in the stair dialog and first deactivate the cut in the stringer that we previously defined for the miter plate. Then we can activate the merge option here at the bottom. We receive a warning reminding us to only activate merging once the stair is fully defined, because remove cuts can no longer be edited. That makes sense, and for this example we confirm. When we now place the stair, the result is a stair with continuous sheet metal stringers. These sheet metal stringers could now be exported as DXF files and manufactured, for example, on the laser cutting machine. The DXF would look exactly like the side view of the stringer. I will skip the export here and hand back to the moderator. Thank you very much for your attention and for staying with me for so long. Bye and see you next time.